So we have a quadratic function, okay, f of x in general get x squared plus bx plus c, okay? And then we know that the maximum value, okay? So fx has, I did only do one of them because the second one is the same. The value of 2 was f of 3 equals 8, okay? Find f of x. Now, to solve this problem, we needed to use a standard form, x minus h squared plus k. What we know is, first of all, a should be negative, right? Because it's open downward, it has a maximum value. And second, we know that k is going to be the maximum value, which is 2. So at this moment, you only have this information, okay? So now what is next? You plug 3 for x, right? F of 3 equals 3. A 3 minus h squared plus 2. That's going to be 8. Okay. Now, you are not able to, clearly, you're not able to completely determine the value of a and h together. So that's the relationship. Okay, so you can find a particular solution so that you get a general formula. What you should say that, here's a general formula, a equals, okay, well, be careful about this. From this identity, right, what you can conclude, what you can conclude is a is going to be positive. Do you agree? Mm-hmm. So it's impossible. Mm-hmm. So the correct answer should be no solution. You cannot find such function. Sometimes, you know, you get, yeah, that's right. So this has no solution. Now a is negative. So if you let a to be negative, you cannot find h. Yeah, a is negative number, right? So no solution at all. Yeah, the correct answer should be no solution. That's problem number 6. I don't have a solution answer here. Now let's look at the next problem. Maybe it has solution. Okay, a quadratic function. Okay, f of x has minimum value of 7, whereas f of 2 equals -4. Find the f of x. Okay, find the f of x. Okay, so here you see again you will get f of x in the form a x. Oops. What happened? X minus h squared and the plus 7. So this is a minimum. I did not touch any cables. Okay, this is a minimum value. So that means the parabola is open upward. That means a should be positive. Okay. So now you get same here, x minus x squared plus 7 equals, when x equals 2, that's going to be -4. So a 2 minus x squared equals -11. And now what do you see? So that implies a must be negative. Yeah, it's impossible. Okay, so you can say hey, there's a typo here. But if suppose there's no typo here, then it's no solution. Got it? Yes. All right. Now, we have already completed all the subjects we already learned, okay? And what I'm going to do is in June, we're going to talk about problems from math counts as a review of what we learned, okay? We're going to, I'll give you 3 sets of homework from previous math counts, okay? That's a homework. And in the summertime, since I don't have a class I go to China on June 20, so I plan to have a 3 class. If my computer works well, get a new computer, then we're going to have a 3 class instead of 2. So 16 will be the last class, already announced that. And then before I leave, I give you a set of exercise, and those who are still interested in doing this kind of problems, then you can come back in August. Okay, those already will get in the high schools, then don't need to come back, okay? All right, so what I'm gonna do today, we're going to discuss, select some problems, and we're going to, some are easy, some are difficult, okay? And you're going to get a set of 30 problems each time as a homework, okay? So my first question is, we did already have given the following problems: 1, 7, 25, 61, 121. Okay, the first problem is, what is the next term? It's a review, right? Okay, what is the next term? All right, so this is a sequence problem. And what we do is, the very first step is just take the difference to see if we are able to figure out the pattern, okay? So you will see that, it's not an arithmetic sequence, it's not a geometric sequence, okay? So what you do is, you take a difference, okay? And then 25 minus 7 is going to be 18. Okay, so you get so we call secondary sequence. Sometimes it works, sometimes it doesn't work. Then you try a different way, and then 61. Yeah, then 61 minus 25, and you get 36. Okay, it looks like we're going to get a pattern. 121 minus 61 is going to be 60. Okay, so what is the next number in the sequence, right? And you look at this, 6 is, this is going to be 6 times 3. This will be 6 times 6. This will be 6 times 10. Okay, do we have a pattern here? Okay, so what is, and then here will be 6 times 1. Looks like there's no pattern here. It's 1, 3, 6, and 10. It's not like, it's not a arithmetic sequence. Okay, think about this, right? It's not a arithmetic sequence. Okay. So this secondary sequence, if you can figure out next number, then you're okay. Okay. There are only 4 numbers there. There may be many multiple solutions. We're trying to find the more direct one. So it's not increased by 3, right? Increased by 2, by 3, by 4. Actually increased by 3 and 2 and 4. So it's increased by 3, right? 3 is the 1 plus 2. You add the 2, you add the 3, you add 4. The next one you should add the 5. That's a pattern, okay? So now you get, so the next number, x minus 121, is going to be the number 6 times 15, okay? So 6 times 15, then add them together. Yeah, so 1, yeah. It's 90, okay? So then implies x is going to be 211. Okay, got it? So the idea is that the most natural way is take the difference first. Sometimes you can see that already, trying different ways. So the most natural way is just take a difference, you get a secondary sequence, and to see if you can see the pattern in some way, right, to get the next term. Then you go back to solve the problem, okay? So this is about sequences, okay? My next problem is also sequences. This is we know it's a geometric sequence, okay? The sum of the first 3 terms of a geometric sequence what's the definition of geometric sequence? Of positive integers, okay, is equal to 7 times the first term. Okay, that's the first condition. Okay, the second condition is the first 4 terms, okay, is 45. Okay, what is the first term? Okay, a geometric sequence is going to be written in the form, the first term is A, right? And each time you multiply R, all right, so that's called the geometric sequence. Okay, and we know that the first 3 terms is going to be 7 times the first term. Okay, then the sum of the first 4 terms is going to be 45. We wanted to find A. This becomes an algebraic problem. Okay, and what is the best way to do that? All right. Yeah, I don't have space to put up on. That's okay. Right. So you see that you have 2 variables, 2 unknowns, right? So you're able to, you should be able to solve the problem. Okay. So the idea is 45. What is 45? 45 is 3 times 3 times 5. Okay. I'm going to try to find the easy way to solve these 2 equations. So the second one is 8 times, right? And 8, you modify AR plus AR squared, AR cubed. Okay, so you can take R out, for example. And this part is already know it's a 7. It's going to be 7A. Okay, so you can be 7A times 1 plus 7R. So you can simplify it as a product of 2 numbers. Yeah, this is a 7A because it's from the first equation. You don't need to solve it, but just guess and try. And how to guess, you have to find a way to express these 4 terms. Okay, that's called algebra. Yes.
Is it 3?
Yeah, A is 3. All right, but then I know on the other hand, 45 is 3 times 3 times 5. So it seems to me 1 plus 7r should be equal to 15. Or maybe 9, maybe 15. So that's two possible ways. And then, and the A, A could be 3, 1 plus 7r should be 15. That's one possible solution. It's easy to see that, okay, that's a solution. Another possible solution is A equals 5, then 1 plus r equals 9. But then you find out it's not going to be integers. Okay, so this is not a solution. Okay? So from here A is 3 and I is going to be 2, and you can quickly get the answer. All right. All right. So the next problem I want to talk about, I wanted to do that is if the following expression, okay, represents a rational number, okay, what is the smallest value possible value of n? Okay, so here's the expression. This is 3 over 1, 4 over 2, 5 over 3, and the last term is n plus 2 over n. All right, so you have this kind of expression. It represents the rational number as it's radical. It's in the radical form. In general, in the radical form, it's not a rational number. So what is the smallest possible n? So that means, can you express as in order to be rational number, what is inside should be the square of a fraction. Okay, then you can get rid of radicals. If you cannot get rid of radicals, it's an irrational number. Okay, it's an irrational number. Okay, so right. Yeah. So first of all, when you look at that, you find out lots of terms can be canceled out. That's why it's too complicated, right? So there's so many terms there. Then when you look at the last term, it's like a 3, 1, right? 4 and 2, 4 over 2, 5 over 3, and this will be n over n minus 2, n plus 1 over n minus 1, n plus 2 over n. So you will see that those terms and those terms will be canceled out. Okay, so the answer will be n plus 1 over n plus 2 and over 2, and this should be the square of this should be a square of some fraction. Okay, is square of a fraction. Otherwise, this will be the irrational number, right? Then you can get rid of the radicals, right? So you can try, and then it's easy to check. This is always divisible. This is integer, actually. Actually, it's a perfect square. It is integer. Why? The product of two constant numbers is going to be even number. Divided by 2, so it's integer. So it is integer, then this should be a perfect square. Okay, it's a perfect square, then there are not many perfect square there, and then you can, and what's perfect square times 2, right? Times 2, perfect square is 1, right? 2, 1, right? And then 2 square, and 2 right, 3 square, and so on. Okay, I think we have a restriction here. N is n cannot be. Can n be 2? Yeah, n is a positive integer, so n cannot be 0. So this is impossible. Our n is yeah, it's smallest possible value of n. N cannot be 0 because the smallest number is already 3. So here n is greater than 1. So that's the first one. It's impossible. Then after carefully you check, it's 2 times 7 squared. Okay. No, it's not 7 squared. When n equals 7, and this is a perfect square. Okay. When n is 7, and the 7 times 7 times 7 is 8, 9. Yeah. So when n equals 7, then 7 plus 1 times 7 plus 2 divided by 2 is going to be 4 times 9. Right? So that is going to be 2, 6 squared, 36. So 36 is a perfect square. Okay. Yeah, that you just need to look at a few of them, and you can solve for. You see, the perfect square times 2 should be the product to consecutive numbers. You can also do that directly. Just plug a 1, 2, 3. Quickly can get which one gives the perfect square when n equals 7. Right? When n is 7, 8 divided by 2 is, it's already 4. It's a perfect square. And then 7 plus 2 is 9. It's perfect square. So, okay. So that is the way. Okay. So the next problem I'm gonna ask you to do that. I don't want to. Okay. So what is a quotient when 6x to the 2a plus b minus c is divided by 3x to the a plus 2b plus 3c. Okay, can you simplify it? Right. All right, so we just simple, all right? So 6 over 2a plus b plus minus c divided by 3x to the a plus 2b plus 3c. Right? So using the formula, 6 divided by 3 is 2, right? The formula says that a plus b minus c minus a plus 2b plus 3c. So there's the subtraction of the powers. And after simplified, you get 2x, 2a minus a is a, b minus 2b is negative b, and c it's a minus 4c. Okay. So that is, that is the final answer. Okay, just it's not it. Okay. The next problem, it's a little bit tricky. Okay. A right triangle, this geometry problem, has hypotenuse 75 cm and one leg 45 cm. What is the length of the attitude to the hypotenuse? Okay, first of all, you have to draw the picture. So this side, 75. Ooh. So this side is 75, and the other side is 45. You are looking for this H. Okay, this is we go through all kinds of problems today to see if we remember how to do that, right? This is the Jumpship problem, and a very simple application of one important formula in geometry. Okay, and a small trick that I hope you remember. All right, so first of all, you have to find the other side because the right triangle, you have to use the right triangle property. There are a couple ways to solve this problem, okay? So let's look at this other side, let's call the y, right? So y is going to be 75 squared minus 45 squared. But that's a quick way to do because 75 is 3 times 50, yeah. So you multiply this out, and 45 is 3 times 15, right? So this is going to be, no, that's 5, that's 5. So 5 times 3 times 25. Yeah. So, well, we can, it's a 5, 45, 75. Yeah, let's take a 15 out. This is 15 times 5. That's much easier to look at. Yeah, 15 times 5, 15 times 3. So other side must be 4 times 15. That's below proportional, correct? So 4 times 15, which is 60. Okay. So you know this. Now, the next one is the best way to use the area formula. Yeah. What is H?
No, I have the answer.
Yeah. 36, right? 36. Okay. So the best way to solve this problem using the area. The area of the triangle is 1/2 times 60 times 45. But you can calculate the area in a different way. It's going to be 75 times h. Okay. Then you simplify and you solve for h. Okay. So h is going to be 60 times 45 divided by 75. And after you simplify, this is going to be 36. The best way to simplify is going to be 5 times 15 and 4 times 15. And here 3 times 15. 15 canceled out, right? And then it's a 36. Okay, you can quickly get it's a 36. You can also use a similarity of triangle to solve this problem. You don't need a, I'm not sure you should use a yeah. But you still have to find the other leg. Yeah, you probably have to still have to find the other leg. Otherwise, it's yeah, you cannot use the comparison step. Okay. Now our next problem. Our next problem is number series problem. What is the largest even 3-digit number that can be expressed as a product of the 3 distinct primes. Okay, let's understand this question. So you're looking for largest even three-digit number that can be expressed as a product of three distinct primes, but three distinct primes. Prime numbers usually are even number, odd numbers. Now you wanted to make sure the product, yeah, this must be 2 there, 2p times q. Okay, so p, q are not equal to each other and they're prime numbers. Now what is the best way to solve the problem? This number must be less than, much less than 1,000 because it's a three-digit number. Okay, so p times q should be less than 500, right? So that's my hint. Okay, please figure out how to do that. You want to find the largest actually the largest three-digit integer, which is less than 500. So the idea is, I think you begin with the largest possible 499. Okay, 499 is a prime number. You cannot express it as. I think I'm going to make sure the connection is good. It looks like bad. Okay, so it's 499 equals 499. You cannot separate. It's a prime number again. 498. We are lucky. 498. Now 498 is an even number. So when you multiply by 2, and then you will get at least 3 factors there. So that's impossible. I need 2 factors. Okay, I need 2 factors. So it cannot be. It cannot be. Yeah, sorry for that. I need 2 factors, and then the next one is 297. 297. It's a 7. It's harder to factor actually, right? You know, for the 498, it's a little bit easy to do that. I divide by 2, then I get a smaller number. But 497, it's not divided by 3, it's not divided by 9, it's not divided by 11. Okay, but it's possible 1 times 7 gives the last digit 7. So I just trying to. But 49, oh sorry, it's divided by 7, it's obvious. 49 is divided by 7. 7 divided, right? So 49, right, plus 7. So clearly it's divided by 7. But once you divide by 7, then you get 71. So 71 is a prime number. So that's why then you get an answer, right? So our answer here is n is going to be 2 times 7 times 71, okay, which is more than, it's 994 is the answer to the problem. Right? Yeah. Nathan, well, you gotta. I think 497 is the right one. Okay, 497, when you look at this number, make a simple observation. This is divided by 7. Okay. All right, so my next problem is also about the number series. Okay, so we find the two integers between 1 and 100 such that for each, if we divide by 4, the remainder is 3. If we divide by 3, the remainder is 1. And if we divide by 5, the remainder is 1. Wow, it's pretty complicated here. So find the two integers between 1 and 100 such that 1. If you divide by 4, the remainder is 3. Okay?
With the sign?
No, just find the two integers with the same properties. Okay? If you divide by 3, the remainder this time is 1. The third condition is if we divide by 5, the remainder is still 1. Okay, so the remainder is 1. Okay, so how do you solve this problem? There are a couple ways to solve. You know, look at the second two conditions. The remainder is always 1, right? So that means the number minus 1 is divided by 3 and 5. Yeah. So that's uses those two conditions. This number minus 1 is divisible by 3 and 5. That's my hint. Okay, please work on this problem. Yeah. Okay. So that number is going to be divided by 15. Okay. So it's in that form. 15 is a pretty large number. Right. So then you just write down all the possible solutions. Right. So you get when Q is 1, 16. Right. When Q is 2, 31. When Q is 3, 46, and 61, 76, I think 91. So there are not many choices there. Then you find the one which is when you divide by 4 gives you a remainder of 3. Okay, when divided by 4 gives you a remainder of 3, and this is the 1, and that is the 1. Okay, you just quickly do the computation one by one. Okay, so it's yeah, those are the two answers. Okay. All right. Our next problem is it's counting problems. In how many different ways 15 indistinguishable dimes can be distributed among 3 students if each has received at least 1 dime. Among 3 students, okay, the condition is each must get at least 1 dime. Right? So we have 3 students. Let's call it S, F, and H. Okay. So say for Susan, Frank, Harold, for example, right? And then you have 15 dimes. So that means if the first student gets number of S dimes, the second one get a number of F. So the sum should be equal to 15. And each of them should be greater than 1. And we want to see how many combinations you're going to get. Okay, how many combinations you're going to get. Okay.
Is it at least 1 time or greater than 1 time?
At least 1 time. So you write down the 3 conditions. That's not a. Sophia, you have a answer?
Yes, 220. 220.
220. Any different answers? Right? Are you working on the problem? No? Just waiting for my answers? You see, you have 3 variables. That's the only problem here. So you have to think about how do you let one of the variables be chosen. You have how many choices for S, right? S, the smallest value for S and the largest possible value for S, okay? And you clearly can see that S could be 1, 2. I think the largest possible value for S is 13, because otherwise F plus H cannot, the minimum value for F plus H is 3. So for each S, you're trying to figure out this, okay? Then you count them, okay? You count this. Look at this, right? So this, if S is 1, then you get 14. Then it's easy to figure out the numbers for the possible values for F, H, and F and H. Okay. So let's look at how do we figure it out. Okay. When S is going 1, F plus H is going to be 14. And then you can see that how many solutions there. You can just let H to be 1, right? 2. I think the last one is 13. Okay, so you have 13 solutions. Then you see the how does it decrease? When S is going to be 2, F plus h is going to be what? Is going to be 13. Then you see that h can be 1, 2, all the way to 12. Okay? I think this is the way we do, right? And when you increase the values and you decrease the value of h. Okay? But at certain point, yeah, when s equals 13, right? When s equals 13, then f plus h is given 2. So h can only be 1, okay? So now it's clear that the number of possible ways to distribute combinations is just sum of these numbers, right? When s equals 1, you have 13 possible ways to distribute those dimes. And then when s is 2, 12 different ways, right? And so the answer will be total number of ways is going to be 13 plus 12 plus 11 all the way to 1. Right? And it's going to be 13 times 14 divided by 2. My answer is 91. My answer is 91. So you, right? Yeah, let me repeat again. So you have 3 unknown variables there. To find all the possible combinations, you have to choose a value for one of them. Then other 2, add them together, you can quickly figure out how many of the possible solutions. Then you increase the value of s in this case, then you will see the pattern, right? How this decreases, right? So you have to have 13 rows here, and then the number of the ways decrease from 13 to 1, and add them together. Okay. Another question is also number theory. We have, whoops. Yeah, we have 4 consecutive digits. Four consecutive digits A, B, C, and D are used to form the 4-digit numbers, okay, A, B, C, D, okay, and D, C, B, A, okay, so this is, we use a 4 consecutive digits. Okay, what is the greatest common divisor of all those numbers of the form A plus B plus C plus D, and yeah, so add them together. A, B, C, D plus D, C, B, A, okay? Common divisor of all such numbers of the form A, B, C, D plus D, C, B, A. So you add them together, right? Now, consecutive digits means they increase by 1. Okay, so that means if A is n, B is n plus 1, C is n plus 2, D is again n plus 3. Okay. Okay. So that's important, right? But the n, the smallest possible n could be 1, 2, 3, 4. I think 5 and 6. 6 is the largest possible value for n. So those are the possible choices. Okay, because those are digits, consecutive digits, then the largest digit for C is 9. So that's a, okay. So the question, how do you figure out the greatest common divisor of all such numbers? Okay. You have to do something for the A, B, C, right? A, B, C, D can be written in the form 1000 A plus 100 B plus 10 C plus D. Okay, then CD VA is going to be 1000 C plus 100 D plus 10 B plus A. Okay. DC, oh, okay, DC. Yeah, DC. Not the CD. DC, okay. Okay. So we add them together. We will get 1000 A plus D and 100 B plus C and 10 B plus C and D plus A. But then so far we don't see anything, right? But you have to use the relationship between A and D. A and D, look at A and D is a 2n plus 3. Okay, everything 2n plus 3. A plus D is 2n plus 3, and B plus C is also 2n plus 3, and 10 is B plus C is also 2n plus 3. And D plus C is 2n plus 3. When I look at, yeah, D plus C is 2n plus, D plus A, yeah, 2n plus 3. So when you take this out, you get 1, 1, 1, 1, 2n plus 3. Okay, so all such numbers contains the fact 1111. Okay, so the answer is clear right now, and this is the answer. The answer is 1111. Okay, so you should be able to express, express this sum, and then as a product of some numbers, and there's a factor which shows up. Okay, just like a product of 3 consecutive numbers divided by 6. How do you prove that, right? It's in general, right? And you can use special numbers to check, but in general, you have to find a way to express 3 consecutive numbers. Then the product will contain a factor of 6. Okay. Well, I'm going to postpone the class a little bit because we started late. If you have to be in a hurry to leave earlier, you can leave earlier. Okay. Otherwise, we will continue for a few more minutes. Okay. So our next problem is a geometric problems. I hope you can figure it out. And I saw this triangle. It's going to be inscribed in a circle. Okay, this side is going to be equal. The base side is a 6, and this side is 5 and the 5. Okay, find the radius. Right. Yeah, find the radius. Here's a center, right? Now, for geometry problems, you needed to draw addition lines. So the rule is that connect the important points first. Okay, then you probably can see the ideas. Okay, probably you can see the ideas. Okay, so here's what we do. You connect the important points, and what you get is you get a radius, right? R and R, and still we don't get it, right? Okay, so what is next step? What is next step? I have to use the 3 sides information, right? I know that if this is a triangle, it's isosceles triangle, right? If here's 5, 5, 6, if I draw the line in the middle, so this side H is going to be what? It's going to be 4. Okay. Why is 4? It's going to be 5 squared minus 3 squared equals 4. Okay. Because the base is 6, so half of the base is 3. So you can quickly get. 4. All right. So using that information, are you able to get R? So you have to extend this point to here, right? So now we're almost done. When you extend the center to the side, you get a right triangle. So this is the right triangle. Yeah, then express the right triangle, each side of the right triangle. This side is 3. This side is R, right? Yeah. How about the other side? The other side, no, don't use the square root before this. The other side is the height minus R, which is a 4 minus R. Okay? And then you apply the Pythagorean theory to the problem. So 3 squared plus 4 minus R squared equals R squared. Then you get equation in R. Then you solve it. And R squared is canceled out. And 8R is going to be 25 divided by, just 25, right? And then you divide by 8, you get 25 over 8. Okay, so that is the problem. Okay. There are many geometry problems like that. You needed to draw, connect the important points and extend some lines if necessary. And then you see a right triangle there. So you can figure it out you apply the Pythagorean theory to solve the problem. So for example, if you have a piece of paper, right? And this is this side is 4, this side is 8. Okay. Now, I want you to determine the point, right? So that the distance from here is equal to distance to this point, equal to distance to that point. So here's X, X, and X. find the value of x. Okay, it's a similar idea, very similar to the one I discussed. Okay, and this is the equilateral triangle, no, isosceles triangle inside, right? Yeah, please try work on this problem. You cannot leave until you solve the problem. Michelle Ding, get any ideas about these geometry problems? Oops.
X equals 17 over 4.
Huh?
X equals 17 over 4.
X equals 17 over 4. Any different answer? Anyone? Anson? Michael Bao? Okay, this is geometry problem. Kellen, do you have an answer?
No.
No. Anyone? Sophia? You working on that? Oops. Yeah, I hope I can get my laptop next Tuesday. Yeah.
Next Tuesday?
Yeah, I have 2 laptops. So one is broken. Other one, I replaced the glass window. Glass screen, yeah.
Brian, do you have an
This is the older one. I have a connection. Okay. So x equals 5, Charleston says. Yes. 2 times square root of 5. All right. Let's see what do we get. Okay. I have to extend this line. Then I get a triangle, right? A triangle, right? Okay. So you have the right triangle. You see, you have to extend some lines. So this is the x. This is the 2. So how about the other side? You have to express in x before you apply the Pythagorean theorem. 8 minus x, right? Because the total length of the rectangle is x, is 8. 8 minus x. Then you apply the Pythagorean theorem. I don't think you get radicals here. Okay, 2 squared plus 8 minus x squared equals x squared. X is gone, so you cannot get a square root of x. So x squared, yeah. So 8 squared minus 16x plus x equals 6 squared. So x squared is gone. So that's why you get fractions. So x equals 4 plus 64 divided by 16. Okay, so 68 divided by 16. You can divide by 2, right? And then you simplify a little bit. Yeah, let's see if we can divide by 4. Yeah, yes. 17 over 4. Yeah, 17 over 4 is the right answer. Okay. Yeah, see, we've gone through all kinds of problems, right, and techniques. So our next one is the very last one. Is called counting. Okay. So our next problem is radio stations use 3 or 4 for their core letters. If the first letter must be W or K, how many different core letter strings are possible if no letter can be repeated within a string? Okay. So let me write down the condition. The first letter must be a W or a K. Okay. And my question is how many different core strings are possible if no. Yeah.
Wait, how many letters? No, how many letters?
So, how many letters there?
Yeah. No, like how many letters can you use?
You can use any of the letters. That cannot be.
How many? Yeah, how many are allowed to be used?
Oh, use a 3 or 4.
3 or
4, yeah.
Is it 125? 100.
Much larger.
328,800. I got 13,448. I got 28,800. It's probably wrong.
Right.
Yeah, what's your name?
So, you write down the 4 patterns. The first pattern is threes, right? And K star star and K star 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 3. So this can be any of the letters. Yeah. Right. So for the first one, you see, for just repeat it by 2, right? For the first one, this one, how many letters you can choose, right? You already use a W, so you cannot use W, so it's 25 letters. Then the third one, only 24. So multiply them out, 600. So begin with W. Another 600 begin with K, with 3 letters. Then for W star star, 3 stars. Then you have a 25 times 24 times 23. Okay, if you multiply them out using calculator, it's going to be 13,800. So total will be 600 plus 600, add them together, multiply by 2. So total is going to be 600 times 2 because the last begin was k. And times 2. So that is going to be 28,800. Okay? So I stop here. I apologize for my computers. Yeah, usually it looks fine. And so now this is I have a little bit trouble at the very beginning.